suppose I'd better talk a little bit about the mid-semester test. So you know after the holiday you have a test in maths and a test in physics.
Same day, is it?
I don't know the days. I think the maths will be on Tuesday. I think so. Monday or Tuesday. The physics I don't know. I think, let me see. What days do we have physics? We have physics on a Wednesday, Thursday and Friday. And it goes 3, 2, 1, the hours, isn't it? Any day that you would prefer for the physics test? A Wednesday? Because I was thinking, I probably don't want to do it on the Wednesday because you probably don't want to have a class and a test on the same day in physics, you know? So I think in Thursday or Friday. But I'll have a look at your timetable. I don't know where your chemistry is. Do you have chemistry? Monday. I think Lorraine wants to do the chemistry on a Monday. So we might do physics on Thursday or Friday, okay? But if you want to prepare for physics, all you need to do is, all you need to do for the physics test is practice the questions I gave you in class. That's all, okay? So,
how long were they?
I haven't decided. Sometimes I do 1 hour, sometimes I do 2 hours. It depends how much material I still have to do, if I'm behind or ahead of schedule. So, either way, it's going to be questions like in class, okay? And you have a practice test for maths online, so I think you should have enough. Yeah?
So we don't have top paper for physics?
No, because the physics test isn't graded. The maths test is worth 10%. So I'd like to give you past papers to practice, but the physics is just a progress test, you know, see how you're doing? So I'm not so worried about giving you past papers and that. I just think it's better if you look at the worksheets and just see how much you can study and how well you can do. And it'll be good experience because then you can see what is easy and what is difficult for you. So it's good this way. Okay? But we can talk more about the test on Friday. Alright, so what we're going to look at today. So last week, if you remember, we finished with turning forces. Now the lesson we have today, both lessons today actually, they're not new lessons. What I mean is there's no new formulas or no new rules for today. It's just more about using what we've learned so far for different types of problems. So what we're going to look at are problems which are called connected particles. Yeah. Okay. Okay, so I'll just go straight in and give you an example, because like I said, there are no new rules. I'll just give you an example, okay? So my example I'll give you, let's see. I will have this here. Okay, and then let's have a rope here. Oh, nobody said anything. There we go. We have a rope here. And then we'll put a 20 kg here. And then we'll make this angle 30 and then this angle 20. And most importantly, this is not moving. It is in equilibrium. This means all the forces cancel. Yeah, so this is my example. It's like the first one. Now, Ugo, for example, Ugo, how many forces are on this 20 kilogram box? How many forces are acting on it? 3 forces. Can you see 3 forces? Louise, can you see the 3 forces? Can you tell me what they are?
Okay.
Yeah?
The one forces?
Yeah, tell me the forces, what they are. Or is my question unclear? Yeah, what's this one called? Do you mean this one? What's this one called? What's its name? Ah, no, the name of this force. You're right, it's Newton's for force. Which one? No? Yeah, 9.81, yeah, that's what I meant, yeah. Yep, simple as that, yes, weight, 20G. Yeah. Do you know what the other forces are? There are two more forces. Yeah, think, yes.
Another 2 points?
Yeah, well, these ones called. Yeah. Do you know who?
Extension.
What's it called?
Tension.
Tension. Yeah. Yeah. I thought you said extension. Tension. So, Louise, these forces here, because from the rope, these forces are called tension forces. Okay, and this is called a weight force. Yeah. So we'll just call this force T and this one S. Okay. Now, if you look here, this angle is 30. What's this angle here?
Yes.
It's 30. And this angle? 20. Now, if you don't know why, let me show you why on the side here. When you have a Z like this angle and this angle, they're the same. So that's what it's like here. It's like I have a Z. So this angle and this one are the same. And then this one and this one are the same. Okay. Right, we'll go back to Louise. So Louise, can you tell me this force and this force? Yeah.
The left
Yeah.
is the 20.
No.
13.
Yeah. No. I'm getting confused. Yeah. Maybe young. Tension multiply what? T and then multiply. Not 30. You forgot the cos.
Other cos.
Yeah, T cos 30. Yeah. And then young. What's this one here? This one. This is T cos 30 and this one here? Oh, you don't know? No, it's okay. Yeah, this one's sine. This one's T sine 30. Okay. And then, of course, the other one here, sorry, my diagram's getting a bit unclear, I know. This one, you know what I'll do? I'll just draw it again over here. So here's the box. This one here, Louise, we said is T cos 30.
Yeah.
And then, what did you say this one was? T sine 30. Okay, and then this one here? Oh no, this one, going down? 20G. Yeah. Okay. Ibrahim, can you give me the two here from the S?
S goes 30.
S, yes, right, yeah. S cos 20, and then this one here? S sine 20. Okay. Okay. So, are we happy with how I got these or not? You can see how I got these? Yeah? Is it okay? Yeah? Young, is this okay? Or there's a problem? So my question is, you understand or you don't understand? Okay. So I'll draw it here on the side. So if you look, if this here is, say, 40 degrees, and then this here is 20, this one is 20 cos 40, and this one is 20 sine 40. So you can change this into 2. So for example, do you have your calculator, Ugo, or someone? So this one here, if this is 20 newtons, can you tell me what 20 cos 40 is, and then 20 sine 40?
15.3.
15.3 newtons, and here? 12.8. 85 newtons. So what we do, Young, is we take 1 and then we split the 1 into 2. Okay, so then this one here, I write it equals this one plus this one. It's like I break it. Okay, and you see here, the one that touches the angle is the cos, and then the one which is away from the angle is the sine. So if it's with the angle, that's the cos, and then if it's the one which is far away from the angle, that's the sine. Okay, so this is good for revision as well for other people. So if I go back here, so the T I break, and the S I break. So that's what I have here. And then this one is the same, no change. Okay. Louise, can you tell me what I should do next? What should I do next? So I shall also tell you it's not moving. It's balanced. Yeah? Do you know what to do next? Is Ugo distracting you? Turn around, Ugo, and stop distracting her. Do you know what to do next? Or maybe Abraham, do you know what to do next? Oh, of course, we want to find T, but how do we do that?
The forces up equal the forces
Forces up equal the forces down, and the forces left equal forces right.
Actually, your question is finally.
My question? Yeah, what to do next to find S and T?
Okay.
Yeah, my question was unclear. So sorry. Okay, so if you understand what we do next, we say the up equals the down and the left equals the right. So now we get T sine 30 plus S sine 20 equals 20G. And we also get T cos 30 equals S cos 20. Now I need your calculator because I need to put in the sine 30, the sine 20 and the G, okay? So what's sine 30? Is that a half?
Mm-hmm.
So that's a half T, 0.5T. And what's the sine 20? 0.34. Okay. And what's 20G? It's got to be 19.62? 196. Yes, 196.2. What's cos 30? It's like root 3 over 2. But what's it as a decimal?
0.866.
T minus, and what's cos 20?
0.94.
F equals 0. So what have I done? Well, now I have a problem which we can do in maths class. Which method do you want to use here? Substitution?
You find it's either S for the second one and then something for the first one.
If that makes you happy, yeah. What else could we use? let's use matrices. So let's use matrix method to solve this, okay? So matrix method, I get TS equals 0.5, 0.34, 0.866 minus 0.94 inverse 196.20. Okay, good. Right, so you'll need, Ugo, do you mind getting me this one minus this one, the determinant? Okay, so that'll be 1 over Have you got it there for me? Just the determinant, yeah.
0.7 and minus 0.764.
Minus 0. Yeah, 0.7.
6444.
Okay, that's fine. Alright, so we can get the answer for T and S now. T equals this one multiply this one. So T will end up being 0.94 multiply 196.2 all over 0.7644, which is a number. So can you hit that in on the calculator? And then S will be these two multiply these two. So 0.866 multiply 196.2 all over 0.7644, which is also a number. So if I have those numbers, please. T is 241.
241.2.
Okay, 241 will do. And then the S. Okay. What do you think about this question? Compare it to last week. Easier or more difficult than last week? Easier than last week, yeah? So I think this is a good question in the exam. It's not too difficult, is it? Not too difficult. I mean, I could do another example, but I feel like I don't need to do another example. Tell me what you think. Do you want another example or not? What's your feeling? How do you feel? Do you feel like you want another example or you don't want another example?
Well, wedge example.
Huh?
Wedge example.
Wedge? Oh, that's the next lesson. Yeah. No, today, the first lesson is going to be ropes. Yeah. What do you think, Louise? Don't be shy. Do you want another example or not?
An example of something going off the table.
Table one maybe, yeah. You want another example? Yeah. I'll do another example, okay? But I'll try and make it a bit more difficult. Let's see. But not too difficult.
Sure, I have a question.
Yeah, about this, yeah?
Yes, this one. Before...
Go back?
Let's go back, sorry.
Yeah.
And it was...
Back more?
This is the sum.
Yep.
Sum, yeah. The 0.866 minus... the 0.866
Yep.
minus. How do you get the minus? Why do you know the minus?
On the 0.866?
T minus 0.
Oh, T, oh yes, here. This one here. How did I get this? Yeah. It's this one here. I just wrote this to the left. I just moved it over, that's all. Yeah.
Thank you.
I'll give you another example, but let me make it a little more difficult. How difficult? I don't know. How difficult do you want it? Very difficult.
I did my vote.
I don't know. I'll give you this one. Can I go down?
Yeah.
Yep. Okay, so yeah, okay, we'll try this one. I think this is more interesting. So you have a pole in the ground. So the pole is kept in the ground by 2 ropes. So this angle here, we'll say, is 45 degrees, and this angle is 55 degrees. Can you see it? Sorry, 45 and 55. Now, we'll make this 100 kilograms. Okay? So there are two more forces which I haven't drawn. What are the 2 more forces I haven't drawn? Well, yeah, the tension. Okay, I'll just draw it in. So there's a T here, and then there's an S here. Okay, what else have I not drawn? Gravity pulling it down.
Yeah.
And the reaction, very good. So there's also a 100G this way. And as you said, Abraham, what's the other one called? Going up?
Yeah.
And where does this come from? From the ground, yeah. Okay, so what we do next, this here is 90, and this here is 90. This angle plus this angle plus this angle, what should the total be? 180. So if this is 90, and this is 45, then this one is 35?
45.
Sorry, I'm being stupid. 45, yeah. And this one here is 35. Yep. So what I'll do now, can I go down? Yep. So I'll just draw this again. Okay, so here's the top. We have 100G, we have an OR. Now what I need to do, so here's your chance again, Louise. You can tell me, how much is this one? And then how much is this one? So how much is this one? Can you see it?
This one is
Yep. Don't panic, okay? What do you think?
Cos 45.
Correct. T cos 45. Yeah. And then the other. Yeah.
I must put the T.
Oh yes, definitely. You must. Yeah. T cos 45, and then this one here is T sin 45. Yeah. Yes. Yeah. And then this one here, the S cos 35, and then the S sin 35. Okay. So if I draw them in here. What did we say this? I did this one first. What was it? Cos, wasn't it? T cos 45, and then this one here, T sin 45. S cos 35, and then here, S sin 35. Yeah? Okay. Now, if you look at this problem, doesn't look like we have enough information. How many things do we not know? 3. What are they? T, S, and R. How many equations can we make? We can make 2 equations. We can say the up equals the down, and the left equals the right. I need a 3rd equation, don't I? Now, what we could do to make the 3rd equation is we can say, if you look, the clockwise equals the anti-clockwise. But I don't want to do that today, because that was last week. Okay? So what I'll just also say is, I need to give you, in the question, one of the answers. So I'll just tell you that I'll give this to you, 250 newtons. Now I'm giving you that in the question to make it a little shorter to do. I made it too difficult. That's the problem. Because you need to make 3 equations. So you could also say about the turning forces, but then if you want to use the turning forces, then I have to give you the height as well. And we could make this as the turning point. I don't want to do that today. That was last week. So what I'll do is I'll just give you this answer. Okay? So we know what the T is. Okay. So we say the up equals the down. And the left equals the right. Okay. Now this one here is really, really good. Because, do we know the T? Yes. So we can know what the S is, no problem. S equals T multiply sine 45 over sine 35. Can you tell me what that is? .2. Okay, and then what we can do is we can take this answer for S in here, and we already know what the T is, so we can get the OR. OR equals T cos 45 plus 981 plus S cos 35. What's that, so? $1,410. Too difficult now? You said you wanted a difficult one, didn't you? You have a question, Louise, or are you just thinking? Okay. If you look at your page, it's not this difficult on the page. If you look The first example is like question 1. And so is number 2, and number 3, and number 4. They're all pretty similar, aren't they? Let me see. Okay. So right now it's 2:40. So I think, how about you try these for 20 minutes? Well, I don't know. I think there's 4 questions. Maybe 5 minutes per question? What do you think? 5 minutes is too short? Or too long?
Just that you might get parts of the questions.
No, they don't get more difficult. Okay, well why don't you do these for 20 minutes and then we'll start the next lesson, okay? So, question 1, 2, 3 and 4. If you can do them now.
Okay.
Okay? Yeah, so 1, 2, 3 and then 4. Okay. Why don't you sit together? Why do you spread out? Huh?
Like-
It's your style, is it? You like your space, yeah?
Yeah.
Okay.